Soil erosion. Soil erosion is a major form of land degradation. It comprises various processes that are described separately below. However, any one of these processes may occur in the same locality, either in combination or at different times of year. Soil erosion by water is often quite widespread and can occur in all parts of drylands where rainfall is sufficiently intense for surface runoff to occur. This category includes processes such as splash, sheet, rill and gully erosion. Splash erosion is commonly the first stage of water erosion and occurs when raindrops fall onto the bare soil surface. Their impact can break up surface soil aggregates and splash particles into the air. As water runs over the soil surface, it has the power to pick up particles released by splash erosion and the capacity to detach particles from the soil surface. This may result in sheet erosion, where soil particles are removed from the whole soil surface on a fairly uniform basis. Where runoff becomes concentrated into channels, rill and gully erosion may result. Rills are small rivulets of such a size that they can be plowed over with farm machinery. Gullies are much deeper, often being several meters deep and wide, and form a physical impediment to the movement across the slope of farm machinery, even people and livestock. Soil erosion by wind is also widespread throughout drylands that are exposed to strong winds. It includes both the removal and redeposition of soil particles by wind action and the abrasive effects of moving particles as they are transported. In areas with extensive loose, sandy material, wind erosion can lead to the formation of mobile sand dunes that cause considerable economic losses through engulfing adjacent farm land, pastures, settlements, roads and other infrastructure. Gravitational erosion tends to be more localized in regions with steep, rocky slopes and in mountain ranges. On sloping land, when soil is saturated, its weight increases and the downward forces of gravity will induce a relatively large downslope movement of soil or rocks, for example landslides, slumps, earth flows and debris avalanches. This mass movement of material may be very rapid and involve large volumes of soil, but is usually limited to isolated and localized events. Landslides may be natural events, however, their frequency and severity is likely to greatly increase following deterioration or loss of the natural vegetative cover by logging, overgrazing or clearing for cultivation. Freeze/thaw erosion is restricted to high altitude areas and areas with cold climates. It occurs when water in the topsoil initially freezes and expands, then melts, damaging topsoil structure and enabling loosened surface soil particles to be carried away in meltwater runoff. It is primarily a natural process rather than one which is accelerated by particular human activities. This lecture covers only the assessment of soil erosion by water. The term badlands is currently used for areas of unconsolidated sediments or poorly consolidated bedrock, with little or no vegetation. They are useless for agriculture because of their intensely dissected landscape. They appear to offer in a miniature spatial scale and a shortened temporal scale many of the processes and landforms exhibited by more normal fluvial landscapes, including a variety of slope forms, bedrock or alluvium-floored rills and washes, and flat alluvial expanses similar to large-scale pediments. Although badlands evoke an arid image, they can develop in nearly any climate in soft sediments where vegetation is absent or disturbed. General reviews of badlands and badland processes are provided by Campbell and Bryan and Year, including discussions of the climatic, geologic, and geographic setting of badlands, sediment yields, host rock and regolith variations among badlands and field measurements of processes. Badland landscapes are typically asymmetrical. The sunny aspects show impoverished or null vegetation cover because of the strong control on water availability affected by radiation, whereas the shady aspects may bear a vegetation cover close to 100%. Steep slopes and gullies do not allow the formation of a developed soil because erosion processes are either frequent and/or intense. Typical badland form at Pisticci, Basilicata, southern Italy, with southern eroded side and northern vegetated side. Calanchi and Biancanesites considered peculiar forms of badlands evolution. The term Calanchi describes the dendritic network of slope forms created on a single hillslope scarp. An individual kalanchoe is defined by knife-edged ridges, separating small hydrographic drainage networks with horseshoe-shaped headwalls. Biancanesites small, conical or dome-shaped forms up to 20 meters high, which may occur singly or in groups. Calanchi is the result of a rill erosion. Rill erosion is the removal of soil by water from very small but well-defined, visible channels or streamlets where there is a concentration of overland flow. In general, rill erosion is more serious than sheet erosion, and it is most accentuated when intense storms occur in watersheds or sites with high runoff-producing characteristics, loose, and grading operations. Rill erosion is often described as the intermediate stage between sheet and gully erosion, and occurs by a concentration of runoff or low points through the soil. Gully erosion could be considered as an advanced stage of rill erosion, where surface channel gullies, intermittent stream channels larger than rills, have been eroded to the point where they cannot be smoothed over by normal tillage operations. Underground, groundwater, erosion is the removal of soil caused by groundwater seepage or movement towards a free face. It is also known as piping and occurs as a result of bank drainage or, in general, when seepage forces exceed intergranular stresses or cohesive forces. Pipes can form in the downstream side of earth dams, gully heads, stream banks, and slopes where water exits from the ground. Once a cavity, pipe, forms, it is able to enlarge quickly since the flow follows the path of low flow resistance. Typical morphological features of the landscape forms in Mediterranean area, Aliano, Basilicata, southern Italy. The main factor controlling badland formation is the particular character of the rocks or other materials which form the base for the interaction of weathering and erosion processes. However, the existence of other risk factors such as climatic condition, human activities, geomorphological exposition, structural features, encourages the intensification of erosion and development of morphological features of the landscape forms. Soils in badlands deserve special attention, because soils are the interface between the lithosphere and the atmosphere, and so constitute one of the key elements either favoring or restricting the initiation of badland formation. When soils are resilient against erosion processes, gullies do not form. However, when soils, either because of their particular ground cover, i.e. sparse vegetation, and/or intrinsic properties, cannot withstand erosive forces, the topsoil is eroded and deep gullies develop, which may give rise to badlands if the underlying material is also erosion sensitive. Consequently, the characteristics of the materials underlying soils are crucial for the development of true badlands. Lithology is a major factor for badland production, and is probably of greater importance than tectonics, climate, topography or land use. The general characteristics of a soil, regolith or geological formation that favors badland relief are the unconsolidated or very poorly cemented material of clay and silt, sometimes with soluble minerals such as gypsum or halite. Specific characteristics, like structure, mineralogy, physical and chemical properties, may play either a primary or secondary role in material disintegration and badland development. In the Mediterranean area most parent materials are essentially silt-dominant, with clay as the second particle size, while sand is generally very poorly represented. Texture depends on four factors: particle size distribution, grain shape, degree of crystallinity and relationship among grains. Of these, particle size distribution plays the key role in susceptibility for material disintegration and erosion. The larger the range of particle sizes, the higher the degree of packing, and hence the greater resistance to breakdown processes. Conversely, the narrower the particle size distribution, the higher the susceptibility for material disintegration, piping and, consequently, for badland development. Besides textural properties, porosity is the second most important physical property. If suitable macropores are available within the material for enlargement, dispersion can encourage the rapid enlargement of subsurface pipes, a process sometimes referred to as piping or tunneling. Infiltration is defined as the process by which water enters the soil. Its rate depends on soil type, soil structure and soil water content. Infiltration is important for reducing runoff and consequent erosion. Increased soil compaction and loss of surface structure, reduced aggregation, are the main factors in reducing water infiltration rates in soils. Such rates are normally dependent upon the occurrence of large pores occupying the upper surfaces of the soil, therefore they depend on soil texture in the first place.